Hey everybody, this is Alex Merced, and I want to talk about today is I want to talk about cloud costs or cloud infrastructure costs. Okay, so oftentimes the cloud is pretty cool, and again, there's a lot of benefits, like using platforms like AWS, Google Cloud, Azure, and many of the other sort of cloud platforms that exist. And again, there's a lot of upside to using cloud. One, it's much easier to manage because again, you're not handling physical infrastructure, having to sit there and network a bunch of computers physically and see how many, think about, hey, what capacity do you need the next quarter, and having to order machines to then add to that network or subtract from that network. And you just basically say, hey, this is what I need, and it exists. Okay. And at a smaller scale, it can actually be quite the cost saver, because when you're at a small scale, I mean, basically the cost to get started is going to be much lower. Okay, for you to have what you need to function, and then again, when you don't need it anymore, you just stop using it. Okay, so you don't have ongoing costs, and it's much easier to spin down your costs. Okay, now as you get to higher and higher scales, okay, sort of the convenience becomes the outweighing benefit, because of that you do get to a point um, where the bill gets kind of big. Okay, and the bill gets big because you're paying for what you use. Okay, and you're using a lot. You get to a point. Now the question is, like, where are those costs coming from? Okay, there's storage. Okay, and so again, when you're using object storage, you're not just paying to store like a file. So like if I store a CSV file on S3, I'm not just storing a single copy of the file. There's going to be multiple copies of the file across different computers, different machines that AWS has. So it's replicated, okay, because it's a distributed file system. So it's meant to give you that 90, that those, was it the 99s, 99.9999999% uptime. Okay, and the way it does that is that everything is redundant, so that way when something breaks, things keep working. Okay, so again, if I'm storing 10 gigs of data, I'm really storing more than 10 gigs of data because of the replication factor. Okay, that's again the benefit of distributed file systems. Okay, versus using just a file system on my computer, I get that uptime. And there's a cost to that storage. So again, the more you store, and oftentimes, the cost of object storage, which basically, again, is how object storage works, is that basically what you see, like when you interact with your data, it looks like a normal file system with files and folders, except those files are now referred to as objects. And really, the objects are really just a ball of metadata that then the distributed system can go use to figure out, okay, hey, where which computers have this file, and which computer itself is the best one to get from at the moment to get the fastest pull of the file. And there are different costs to that storage, because nowadays there's different levels of what's referred to as tiered storage, because what happens is that you might have files that you don't access for years or you may never touch. Okay, and then you have files that you access on a very, very regular basis, and you need the extra speed to access those files. So now there's like tiered storage, where there's faster tiers, where basically, when you might hit throttling, those like limits may be higher. The basically you're gonna get the creme de la creme, as far as being able to pull those files down fast and get the maximum replication, get maximum uptime for those files. Then you have sort of cheaper forms of storage, oftentimes referred to as like cold storage, where the idea here is that it's just like essentially a lower priority tier. It might not be as replicated. It may not be on in as across many regions. So again, depending where you're pulling the data from, it may be slower. In generally, the idea is you're not accessing the data that regularly, so you don't need the extra sort of performance. So it's put on different types of machines that have different types of networking that can facilitate that lower cost point. Okay, so exploring that those different levels of storage are one way to kind of help manage your costs. Being able to kind of come up with a system and thinking, okay, because basically generally what you do is you have different units that you store your data called buckets. Okay, so think of a bucket as just like it's literally just a bucket of objects. Okay, and generally it's oftentimes at the bucket level that you're going to set these different tiers. So having the sort of buckets that have lower tier storage versus higher tier storage, and kind of thinking through, okay, sort of what data should fall into which bucket and storing them in the appropriate spots to get sort of the maximize the cost. Then there is compute. Okay, so compute is like actually running code. So this generally comes in two forms. Either you deploy an actual virtual machine, okay, which is oftentimes referred to as an instance. Okay, so on AWS, these would be EC2 instances, would be the appropriate, equivalent name on Azure and Google Cloud. But you would provision these virtual machines and run software on them, or run code, or run whatever you want to run on them, and you pay for how long that computer is running. For literally every second that computer is running, you're paying for that. And the more powerful a computer it is, the more expensive it's going to be. Generally, I think like the cheapest is generally like $5 a month if you left it running 24/7. So there's like two models for this compute. There's what's called, there's that, and then there's serverless. Okay, and with serverless, the idea is that instead of you setting up your own machine that is constantly running and you pay for it constantly running, what you do is you kind of write sort of functions, or you write something that can sort of be run on an on-needed basis. And essentially essentially you'll have the way I always like to think about it is, imagine that I have like a web server and I have a web application with several routes, and then what I do is I charge you rent to have a route on my web server, and you pay me for every request to your route. Okay, so in that case, I'm going to share my capacity with you, and then you only have to pay for the request. So you're not paying for running the computer all the time, but you are paying for every request that hits your specific route. And in the same way, something like AWS Lambda or anything you hear that's called like serverless generally kind of works that way, in the sense that it's only up when you basically run it on an on request kind of basis. But oftentimes the term serverless really just means like, hey, you don't have to manage the instances. You don't have to deploy the instances and run the instances. It's managed elsewhere. But like there's serverless functions. Again, you're paying per every run of the function. You see there's like serverless databases, which you're instead of paying for running a database full time, you're paying for the reads and the writes. There's different models for this. But there's that compute cost. Okay, so oftentimes, there's a point where one makes more sense than the other. So generally, oftentimes when you're at like low levels of usage, serverless makes more sense, because you're maybe running a function, so many times a day, or only doing so many reads and writes. Then what happens when you start doing lots and lots and lots of reads and writes, and you're doing lots and lots of requests, then it makes more sense. You'd be cheaper off if you were running your own instances. The problem is that it's not, when you switch from one to the other, in today's world, it's oftentimes not so simple. Like if I had, a bunch of microservices running as serverless functions, it wouldn't be so simple for me to then rewrite that into its own sort of server application nowadays. I think there are efforts to make that more integrated, where you can write code that can kind of switch between both worlds in a more easier way. But that's always like the thing. It's like yes, there's this sort of like there's these two ways, and one way is cheaper, one point, but switching between the two is oftentimes harder. So this is like a situation that a lot of people are running into now, where they have these large applications or large pieces of infrastructure that are built on top of serverless, and then they hit the point where serverless is, where basically now running their server makes more sense, and that transition back is very, very difficult. Okay, although again, the upfront cost of running your own server when you don't need all that capacity, again, also is cost prohibitive in the beginning. So, trade-offs. It's all about kind of understanding sort of what your trade-offs are, what your priorities are, and sort of where you need capacity to manage your costs. And the other third major cost is like egress fees. Okay, what does this mean? Well, basically there's a cost to moving data between machines. Typically, you get charged when you move data outside of a cloud provider or between regions of a cloud provider. So that's where that region thing makes, because there's, again, if I'm sending money from one side of the US to the other, if I'm sending data from one side of the US to the other side of the US, there's a cost to send that data out. Okay, there's a bandwidth cost, and that's being passed on to you. Now when it comes to data infrastructure, where this really becomes oftentimes a problem, is that a couple different times where basically you might have data that for regulatory reasons has to exist in certain regions of the world. So you're trying to join data that is physically located in different places that they have to be physically located because you cannot move it from that physical location. So in Dremio, you might have a Dremio instance in Europe and a Dremio where certain data has to be physically located in Europe, and you have a Dremio instance in the US that has certain data that comes from the US. And then when you join that data, you know, depending on sort of where the specific engine that's running that job is, because you might have two Dremio instances, one in Europe, one in there, and then they share data with each other using the Dremio connector. You know, if I'm running it from the US, well, there's going to be egress costs for moving that data that's in Europe over to the US and so forth. Another place where this happens is like, let's say you use a Snowflake warehouse. The warehouse, when you move the data from your S3 to the warehouse, you may be hitting egress fees moving it out. So basically, not only are you paying for the new storage on Snowflake and the compute that you use on Snowflake, but then you're paying all these additional egress fees. And then on top of that, another thing that people aren't aware of when they're using like, or at least they get caught off guard by this when you're using like a data warehouse platform, is that let's say I were to delete 100 records out of a table, okay, you think, oh, okay, so that's less data, so my storage costs should go down. If anything, your storage costs will go up. The reason being is that the old data is still there. Because oftentimes platforms will offer you what's called time travel, the ability to kind of go back in time and query the data as it was in the past. So the data isn't deleted. Now you've just created another version of the data, which creates additional storage needs depending on sort of what specific transactions you did and the underlying storage and all these kind of things, which are typically abstracted away from you. So you just know that your storage is growing. You may not necessarily know exactly why or how to optimize for that. One of the nice things of using a data lakehouse, because then you have much more visibility into the internals of how like a format like Apache Iceberg or Delta Lake work for you to optimize your workloads to still have the time travel, but not try to plan your transactions in a way that might minimize the storage creep. And then plus storage on Data Lake is just cheaper to begin with because, you know, you're not dealing with that markup for a cloud warehouse platform. But yeah. So there's all those costs. So essentially, again, you're having those egress costs and compute costs and storage costs when you first move the data over. But then as you transact in the data, you have the additional compute costs, and you actually have a growing storage cost because you're creating versions upon versions of the data. Typically, I think the standard is like 90 days that it's keeping the data for. So even if I were to go delete and like bit large swaths of my data, I'm not going to see my storage bill going lower because I still have those historical versions and backups still being stored. So it's just like a lot of these things that kind of sneak up and you know, bite people when they go see their bill later on, because they're thinking, okay, well, if I run these queries and I store, you know, based on what they, you know, I have a gig of data, because you may see maybe you had a gig of Parquet files. So you imported a gig, but now you've done lots of transactions. You're thinking, hey, I still only have a gig of Parquet files. I haven't really ingested new data. But guess what? Now you're storing like 3 gigs because of sort of like his, you know, just the effects of how that data may have been rewritten under the hood, to keep all those historical versions and other aspects of it, and then the costs that come along with that. So, and the gig is a small amount, so I probably should be using like terabytes and petabytes, but you get the idea. So hopefully this gives you a little bit more insight when thinking about like, hey, why is my cloud bill so big? Okay, and that goes on top. And basically, when you're using services like EMS, so that's like the basically or EMR. Okay, so that's basically the Elastic MapReduce. So essentially, you're spinning up these Hadoop clusters dynamically. But again, when you do that, a cluster is not just one computer, it's many computers, so you're paying for all that compute for the period of time that you have to run that. And so then, again, if you use an EMR cluster to run an ETL pipeline, the longer that job takes, the more that job is going to cost. So again, optimizing the way your jobs are run are also ways to cut down costs. We're just running less jobs, and this is where like Dremio is really helpful. Because you can reduce the need for a lot of these pipelines, because you can just basically model everything virtually and basically create what's called reflections where needed, which essentially does require some compute power, but it'll oftentimes be in a much more managed much more lightweight way, and basically a lot less complex way. Um, so you end up reducing your costs along with a lot of its other caching features. They'll reduce the number of requests to S3 and things like that. So yeah, just wanted to talk about that today. My name is Alex Merced. Again, you can follow me over there on LinkedIn, Twitter, YouTube. All the links will be in the podcast episode description. I'll see y'all later. Have a great day and enjoy.